Welcome to the Cost of Everything podcast. This week, I interview Christian Smart, Chief Data Scientist at Galarath Federal. Galarath provide cost and risk analysis to the Department of Defense in the United States and NASA, amongst others. He has most recently worked on modeling the cost of robotics for Earth orbiting spacecraft. So he's got a lot of knowledge about project risk, and that's what we talk about in this podcast. Without further ado, let's just get straight into it. Thank you for joining me, Christian. You're someone who was right at the top of my list of people to start interviewing. So I really appreciate you joining me today.
Well, thank you, Emmerich Paul. I'm honored to be able to take part in this.
I thought what we could do is just give the listeners a bit of background on who you are and how you actually got started in estimating and cost analysis.
Yes, I have been doing cost estimating for around 20 years. I currently the chief scientist for Galarath. Provide consulting services to the Department of Defense and NASA and other government agencies, including the Department of Homeland Security. Prior to that, I had done some work also as a reliability engineer. I have a PhD in applied mathematics. I knew that teaching potentially was not the best choice for me, so I started looking around for a career in industry. When I was getting close to finishing my PhD, I worked in software for a little while. That was not really my cup of tea. I moved over to reliability engineering. I enjoyed that very much. And then I've been doing that for a couple of years. I was looking around for potentially another challenge. And a friend of mine said that they was potentially an opening, and it would be involving doing regression analysis and other statistical type of methods that I was familiar with. So I said, that sounds interesting. So that led to me actually taking a job as a cost estimator, doing some statistical analysis and some programming. So I sort of stumbled into the cost estimating career field, but it works out well for me. I also have a background in economics in my education, so it's a good blend of the two subjects. Cost estimating is not something that you really learn about in school. It's not no traditional career path. You don't go into college and pursue a degree in cost estimating and say, I want to be a cost estimator. That's not the way it typically works. There are not many degree options in cost estimating, so it's typically something that you wind up hearing about from friends or finding about after you start working.
Yeah, it's interesting because I think that's similar to how I chose to go down the route of cost estimating, cost engineering. I've only seen, and it's only since I've become sort of a professional, maybe one or two courses in the UK that offer that as an actual degree. It's usually offered as a 1-year supplementary or a couple of modules in an engineering program. But you do tend to find a lot of people with statistical, mathematical, scientific engineering backgrounds tend to move into this space. It's quite interesting, your background, and defense, aerospace is a huge industry. When you look at America, a lot of people consider things like the Department of Defense and NASA. So I'm aware you've done work with NASA and those kind of industries. Just referencing some of your work and some of the presentations I've seen with ICEA, and you've mentioned before that the cost of defense and aerospace projects can be very high, even compared to some other industries. Although I've seen projects, the nuclear projects that go. Construction projects that go vastly over budget, and also other mega projects. But from your experience in defense and aerospace, why do you think they tend to be cost and schedule over, and why they're subject to cost and schedule overrun?
Yeah, there's just kind of sort of two parts to that. I see. There's an absolute high level of cost in these industries, and part of that is a function of you're not making a profit or loss. You're producing something for the government. So there's sort of a qualitative benefit, which can be very high. National defense, it's hard to put a dollar figure on that, but so there's an absolute high level of cost. And then there's the other side of that is there is the problem of cost and schedule overrun. Talk first about the high level of cost. That's due to several reasons. One is, to some extent, these systems wind up being at the very high end of the performance spectrum. Some of this is rocket science. The old saying, it does not take a rocket scientist. Well, sometimes it does. And that makes it very complex, makes it very hard to complete these projects. And so this is complicated, and you have to pay for that to achieve this performance. But on the other side, you have to look at the balance of these three: the cost, the schedule, and the performance. And if you choose really high performance, you're going to have to pay for it. And there's no saying that around the last 10% of performance is about a third of the cost and 2/3 of the problems. By pursuing that really high end of the performance, you wind up spending more. The government typically does not do enough analysis up front to determine where that sweet spot is between performance and cost. As one Army general told me, why buy a Mercedes when you can get where you need to go in a Volkswagen, right? So if you can achieve it with the lower performance option, you should choose that option. But unfortunately, the government tends to look at the performance. A lot of this is that in engineering is the biggest part of this, in terms of looking at the project management profession. When I used to work at the Missile Defense Agency, we had about 100 cost estimators and we had 1,000 systems engineers. So the system engineers focus on performance, and so they're really driving the system to focus on performance to exclusion of other considerations. Another piece is the fact that the government does not build these systems itself. They hire contractors. And so as part of that, there's a level of oversight, because when you compete a contract, you want to make sure they're doing a good job. And that's given rise to a lot of project management and systems engineering in support of the government, which increases the cost. So all these requirements and these oversight reporting requirements increases the cost. A commercial system can often be completed for between 1/2 and 2/3 of the cost of a comparative government system. Much of that is due to the reporting requirement. There's also additional testing and things that need to be done for government systems, which tend to be more customized and unique and high performance than commercial systems. For example, if you're going to launch a satellite and it's a commercial satellite, it might be something like satellite television service like DirecTV or Dish Network. There are satellites that provide that service. They're done relatively cheaply because there's a certain standard that they build to, and there's a certain amount of performance. But they're focused more on cost because they have to make a profit, one. And two, they're not trying to solve a brand new problem or trying to counter some challenging defense problem, such as counteracting a nuclear weapon or trying to defend against a hypersonic missile. So that's one piece of it. The other piece of it is that there has been a lot of mergers and acquisitions in this industry over time. If you look at the defense industry, at one point there were around 6 dozen. You look at 1980, for example, around 6 dozen defense contractors. From 1980 to 2000, they consolidated to what's now called the Big Five. And most of the work is performed by these. So you have less competition. Less competition leads to more pricing power. You have an oligopoly, so that also increases the cost. As a result, it causes things like the Air Force wants to buy a replacement for a toilet seat cover, and they wind up spending $10,000.
When you told me that was incredible.
Yeah, that's not that long ago. That was just 3 years ago. I think that was around 2017 when that occurred. So they could have used a 3D printer to print the part for around $100 or $200 at the most. So yeah, they really paid an exorbitant amount. So the U.S. government pays exorbitant amounts for defense and aerospace systems. Now that's one part of it. So the other part is the overrun issue, and that has to do with risks. So there's a great deal of uncertainty in these programs. Much more can go wrong than go right. There's a little bit of opportunities for savings if everything goes right, but there's a lot of risk that things will go wrong and will actually increase. It's part of the complex process of project development. There's just so many things that can go wrong, and things can go really wrong. And if you're talking about a large project where you have hundreds of people on staff and you stretch the schedule by a few years, you're talking about massive cost increases. So, there's a lot of risk out there, and the cost and schedule overruns are do a couple of things. One is lack of proper planning up front to some extent. Lack of realism is a second thing that's somewhat related to that. There's something called the planning fallacy in psychology. The psychologists Kahneman and Tversky noted that there's a tendency for people to plan for the best case, not the worst case, and not even the most likely case, which you think should happen, most of the time, but the actual best case. And so that sets up cost and schedule growth from the beginning. It's this drives optimism. Program and project managers are so optimistic. I liken it to a cult. The cult leader Jim Jones, who led the People's Temple cult, they committed mass suicide in the country of Guyana by drinking a cyanide-laced Kool-Aid. So the mantra to avoid don't drink the Kool-Aid is to avoid project optimism and counteract project managers' optimism. So these reasons lead to cost and schedule growth. There's lots of different things. There's some things that you just can't avoid. There's going to be risks that are out there. Projects take years to develop, sometimes even more than a decade. So likelihood of something, some sort of external force happening that will impact your project, funding delay, you you get a change in the presidential administration and the new president decides to cut defense spending. That impacts all projects, that delays schedules, that increases costs. Some of these things the project cannot control, but a lot of things projects can control. And a big piece of it is lack of proper planning up front.
I think there's a level of interdependency between, schedule and cost. Obviously, the old adage, time costs money. I mean, you mentioned about the complexity and it's complexity of the design because it's potentially the first of a kind. There's requirements definition or sometimes lack thereof, and how that integrates with cost and how cost drives design. And then, going right through to the competitiveness of the supply chain and a potential premium that the government might incur given that it is the government. And we talk about overruns as well, and we talk about uncertainty and risk. And just really to go back to the basics here, because whenever I've read various things on uncertainty and risk, sometimes I've heard uncertainty, sometimes I hear risk. It's very interchangeable and it depends what industry you're in, obviously. But what definition do you use for risk and what definition do you use for uncertainty? Do you define them separately?
It's a great question. So when they think about risk, and think about this particular problem, they're thinking about risk, or they talk about risk. Uncertainty is another term that's similar, but it's not as used as often. There's two schools of thought on this distinction between uncertainty and risk. I'll talk about the school I believe in a second. The first school of thought comes somewhat from economics. And if you go back to the 1920s, Frank Knight, an economist at the University of Chicago, distinguished between risk and uncertainty in the following way. Uncertainty was just there's some vagueness about the future, but you cannot measure it. There's some things that you really you don't know. What is there's some chance that the human race will become extinct in the next 100 years, but can you really quantify that? You can try, but it would be difficult. Risk, on the other hand, he defined as something that's more tractable, that you can actually put some uncertainty on. So if you were to flip a coin, you can assign a probability of heads is 50%, and the probability of tails is 50% as well. That's something that's more tractable. A casino game, you kind of know what the odds are of winning at the roulette table or a slot machine. Those are the kinds of things that he considered to be risk. Risk was more tractable. However, I don't follow that, and most of the cost estimating and the schedule estimating profession tends to follow a slightly different definition, where uncertainty is defined as the indefiniteness about an outcome. It includes good events that could wind up meaning that you would take less time, or a project would cost less than you expect. In terms of cost and schedule savings, those are sometimes called opportunities. The flip side of that are the bad things that can happen. So uncertainty encompasses both of those, the good and the bad things. The bad things that can happen are risks. So risks are the events that will generate cost and schedule growth. And I consider cost and schedule growth typically to be realizations of risk. So a risk has occurred. That means you're going to have a cost increase or a schedule delay, and typically those things tend to go hand in hand. Sometimes they'll cause both. Summarize that. I consider uncertainty to be there's some indefiniteness about an outcome. Opportunities are the good things that can happen to reduce it. Risk are the bad things that will happen to cause it to increase. Now, I will say most of the time when looking at projects, risks overwhelm opportunities. If you look at the two and compare the two, risks are much greater than opportunities. So in my work, I tend to use the two terms interchangeably, because most of the time we're talking about uncertainty. What we're really concerned about are the risks.
You can talk about almost an infinite number of risks for the extent to which you have a budget for a particular project, or what would be a reasonable cost for a project. Because we understand that there is a level of optimism in understanding what's going to be delivered and the time it's going to be delivered and the value it's going to provide and the return it's going to give you. And then there is a level of optimism on how much things will cost, how things will integrate. There's so many different layers there. If we don't consider risk and uncertainty, does that mean that we're bad at estimating? How much of interpreting the estimate and whether the estimate includes for a certain set of risks or is presented as the most likely cost, how much of that is down to who is interpreting it and is making the decision using it, and how much of it is the estimator needs to provide that information for the decision maker?
So the estimator needs to include uncertainty in their estimates. You could be as precise as you want in terms of your estimate. If you do a good job of capturing uncertainties and you then encapsulate that or summarize that as a single number, and you have to do that at some point. You have to budget to a single number. You cannot budget to a range. Then you need to look at if you need to look at a single number that best represents that. The mean might be the best single number, but it depends on the amount of uncertainty. If the uncertainty is relatively mild, then the mean might be the best choice. If the risk is really extreme, and for most projects, I would tend to put risk in the relatively mild. It's tractable, it's analyzable category. We have some control over what happens with projects. Project managers can do risk mitigation. They can potentially cut scope to try to cut costs and schedule growth. So there are some ways that they can overcome that. On the other hand, sometimes with public projects, a blank check is written, so you might see extreme cost growth occur. So then, in such a case, wild risk would happen. But I would say in most cases, you would have mild risk would apply, and in that case, using the mean would be good. Now, you have to be careful about that. So you have to make sure that your estimating method is appropriately estimating the mean. What if you were to take a statistical equation and you were to provide, run the inputs? What is the output of that CER? Is it a mean, or is it a most likely, or is it something else? Depending on the type of estimating approach you use, for example, if it's a build-up estimate and you are estimating at the most likely value of the inputs, you may actually not be estimating the most likely output. So you have to be careful about that. For example, if your build-up point estimate does not include things like correlation among your work breakdown structure elements, then the sum of your most likely inputs will not be equal to the most likely of the output distribution. You have to be careful about that. You may be at actually a very low, what's called a confidence level. Confidence level is a little bit of a unique term for cost and schedule estimating, which means it's a percentile of a cumulative probability distribution. So what is the likelihood that your final cost or schedule will come in at or below that amount? So well-known example by the late cost estimator Steve Book, where he showed that summing the most likely values, taking the most likely inputs, running it through a CER, and then aggregating those values, you would come in at potentially, say, a 5% confidence level, whereas the most likely value of the distribution would be more like at the 40% confidence level. So you have to be careful about that. You could way underestimate. You can significantly underestimate the actual costs depending upon your method. If you do something else, like if you do a linear regression analysis, then you should be estimating at the mean, assuming that your inputs are the mean inputs. And you're one of the issues that you have if you're working for a project, and I've done this myself, is that you're somewhat tainted by the project's optimism. So you use their inputs, you run them through your estimating process. Your output is then optimistic. Your risk ranges will also be optimistic for the same reason, because they will say, oh, well, these are the bounds that you consider, and you're going to wind up underestimating that. So you have to be careful about that. As estimators, we need to be careful about making sure we understand uncertainty in our methods and our risk ranges, and making sure that we are actually providing a most likely or a median or a mean value for the output. And we have to be very careful about that, because it's easy to underestimate. We're more likely to underestimate than overestimate.
I've had sort of similar experiences where, for example, if I've done an early stage estimate for a project and I've done it by some sort of analogy with a different system, and I've used some kind of scaling factor, that there'll be one element that I've potentially grossly underestimated. When we get through to the next stage of development and they have a certain threshold limit and we start to get more information from suppliers, for example, we've got more of an idea of how much. There's more sort of semi-bottom up estimating, then they're pulling their hair out because I'm saying we need to value engineer this. Well, not necessarily me, but someone in the team would. It's basically because of where I've put them in the optimism at the early stage. There's a different layer of requirements that wouldn't potentially have been there if a certain amount was accounted for. To me, that's potentially my bad estimating, but given the information that was available at that stage and the level of detail in the design, I'm not sure whether that makes me a bad estimator, or whether it was poor requirements, or whether the assumptions didn't provide enough of a contingency or an allowance, or whether the wrong number was used at that stage. And I think that leads me sort of to the next question, which is along those lines: can we say we're bad at estimating if we get a number like that so badly wrong?
Potentially. There is a lot of uncertainty, so we have to recognize that. So to some extent, it's incumbent upon us to recognize that this is an issue. And this is not, you're not alone in this. And I've been in the same position myself working on a large project where my initial risk analysis, if I looked at the budget just a few years later, that budget was beyond my 90th percentile. So of my, I've experienced that myself. Now, number one, I think, providing an accurate estimate given the inputs that I was provided, but my inputs were optimistic. One of the things you discover as you work through a project is you discover you change your assumptions to be more realistic as the project goes on. So, as we discovered that, our S-curve widened, we realized there was more risk than what we had thought. The perception of risk increased to become more realistic. Does that mean we're bad at estimating? Potentially. I mean, if you can be as accurate as you want to be, given that inputs are accurate, but the outputs are not accurate. But the problem that you're mentioning occurs again and again, over and over again. It's a repetitive process. If you actually look at the cost and schedule growth history, it forms a pattern. That pattern fits what's called a log normal distribution very accurately. So you can actually use that information to inform your risk analysis to make it realistic. So you recognize that you are in the early stages. There's a lot of uncertainty. You can look at that past pattern and calibrate your risk analysis to historical cost and schedule growth, which occurs across multiple industries, across all types of projects. It happens, the big projects often get much of the press because those are where the overruns are in the billions of dollars. But it happens to small projects, $10 million projects, $100 million projects, $1 billion projects, or £1 billion projects. One of the things that we don't do as professionals, we don't look back and see how well we've done in the past. So, it's like we're at a pub and we're playing darts, and we throw the dart, we look at the dartboard, we throw the dart, and then when we turn our head away, we never look at the dartboard to see if we've hit a bullseye or if we've even hit the dartboard at all. As a profession, we need to do a better job of tracking our performance and see how we've done. The best way to improve your performance is to measure it and see how well you've done, but we don't typically do that. Now, it takes some patience and persistence because when you're looking at these projects, they take years to develop. So you have to go back and be willing to look at what you did sometimes 10 years ago to see how accurate you were. So it's not necessarily something that's quick and easy to do. Takes time and persistence, but something that we need to do. We need to do a better job of measuring our performance over time so that we can provide more accurate point estimates as well as more accurate risk ranges of cost and schedule.
The length of some projects and how long before you get, real world data back to tell you more than just the estimates. You might get prices back or you might get some actuals. It depends if you've been prototyping, for example. You tend to have moved on in terms of the work level that you've got to do, or you might have moved on to a different project, or you might, potentially you moved on into a different company. So it is a challenge with how do you get feedback when the world moves at 1,000,000 miles an hour, but numbers don't seem to come back so quickly sometimes. I think just to go along with that, a lot of the work that I've looked at is early stage estimating, and I know there's sometimes a bit of controversy around quantitative versus qualitative. Now, when you're at the early stages, if you've got no historic data, if you've never done that project before, is it justified to use qualitative data to set an early stage estimate? If so, what would you use that estimate for? Is there a limit to where you would use that estimate?
That's difficult. I mean, qualitative estimates or qualitative analysis is fraught with difficulty. Typically, you would try to use the data that you have, or try to find some analogy to historical data where you could at least set an anchor point. Now, the problem with setting an anchor point is you tend to be anchored to that, and if you get later data that tends to point you to something different, you tend to still stick to your anchoring point. So you have to be careful about that, but you need to be cautious about qualitative data. Qualitative methods, they tend to underestimate rather than overestimate.
I've really been fascinated with how we do early stage estimating, given, as we've discussed already, that there are usually time limitations. There's definitely information limitations. So it speaks to that there has to be an element of creativity on the part of the estimator, a little bit of art in there, as well as the science, in order to show the justification, the traceability of their estimate, and essentially get people to trust in the number. And Alan Jones in the UK, MBA systems, they use this sort of estimator confidence level and a qualitative scale to show the level of confidence that estimator actually has in his own number. I think it's trying to align with, it tries to align with the TRL, technology readiness level indicators. What I've seen is that scale is sent almost as a traffic light indicator with the estimate to tell the decision maker, this is based on very little information. This is a confidence level 7 or 1, whichever side you look at as the worst side. Don't use this estimate for anything like setting a budget. Just use it as an indicative figure. You need X, Y, and Z more information before you can use this for anything else. I think I'm almost of the idea that you can't really trust judgment. There's this theories on wisdom of the crowd and all that kind of stuff, but you can't really trust judgment to set your budget or any kind of baseline. Like you say, you'll end up anchoring in the wrong waters, and then you're stuck with that number throughout the project, and you're constantly reminded of that number. We've talked about uncertainty risk. I thought we would talk a little bit about the fact that you've got a book coming out in November, is it? So it's called Solving for Project Risk Management: Understanding the Critical Role of Uncertainty in Project Management. Your background is in defense and aero, but the book actually applies to all projects.
I began writing this book in 2014. I actually sat down and put together a table of contents. I started writing it in 2014, and as I started doing more research, I started updating it. This time last year, I got to the point where I felt like I had a mostly complete manuscript, so I started looking for publishers, ways to get it published. A colleague of mine was actually had a deal with an agent who was trying to get a book deal set up for him, so I contacted her, but I never did sign a book deal with her or an agent deal with her. Tried one other press since my book was mostly on defense and aerospace. I looked at the Naval Institute Press, which has published quite a few defense type books, including some fiction bestsellers like the works of Tom Clancy. So they turned me down, and then I remembered that around 10 years ago, Bill Hazeltine, who was formerly the president of the precursor to the International Cost Estimating and Analysis Association, had a deal to publish a book on cost estimating with Wiley. He was going to basically edit the book and then get different people to write chapters, and he had asked me to write a chapter on risk. So I had basically done that, and then he had some personal things that happened, and one thing led to another, and it didn't come to fruition. But I had written an entire chapter on risk. But I remembered that, and I reached out to Bill through LinkedIn, and he put me in contact with his contact, who is now at McGraw-Hill. He's in the textbook area. My book was actually written for a general project management audience, and actually at that point it was general project management audience in defense and aerospace, not a textbook. He put me in touch with someone who was in a more general business book category. He was a little hesitant because of my focus on defense and aerospace, but he believed that if I would broaden it to a general project management audience of all types of projects, and if he asked me if my what I had found for defense and aerospace would apply to all types of projects, that he believed that McGraw-Hill would publish it. So I did. There has been quite a bit of other works done. Bent Fluberg at Oxford University has done work on infrastructure projects and has found similar types of things for infrastructure projects, rails, bridges, even the Olympics. So I quickly found that what I had done for defense and aerospace would adapt. There's someone working in the construction industry, John Holman, found similar types issues in construction. I found that what I had done would apply more broadly. So they signed a deal, and so I had about 6 weeks to produce a draft manuscript, basically rewrite a lot of what I had done to include examples outside of defense and aerospace. I was able to focus on the book in on my spare time and got it submitted in the end of April. There are about 90 tables and figures in the book to illustrate ideas and examples, because I don't really have advanced equations. It's just some simple examples to illustrate the ideas, but the technical ideas behind them. So the copy editing process, they put together the completed manuscript, all 250 pages with all 90 figures and tables that are in there, and go with the detailed process of correcting that. So it was like a 3-stage process. Every time you get done with one stage, you would go back and you would find more mistakes, and you eventually get towards the end. And I turned that in last week, and now it goes to the printer, and the book will come out. It's supposed to be to appear on bookshelves on November 3rd, which is actually the day of the presidential election here in the U.S.
So you picked a quiet day. So
Yes,
uh,
yes.
no, it's
Fortunately, it's available for pre-order on Amazon and Barnes and Noble right now. Both the hardcover and on Amazon you can pre-order the Kindle version, and on Barnes and Noble you can pre-order the Nook version and the hardcover versions as well. So you just search for "Solving for Project Risk Management." You should be able to find it.
perfect. I mean, we'll put all the links in the description for the podcast and also on the website. But what's interesting is how almost universal it is that project risk is not managed very well. And also, just to backtrack a second, 6 weeks, that is very quick work. I'm guessing a slightly different question. How did managing the timescales, schedules on your book writing compare with how you might have estimated it?
That's a very interesting question. So I basically I set myself a pretty aggressive schedule actually, and I feel pretty fortunate that because of the shutdown, I was able to achieve it. So it was around the time that I signed the book deal with McGraw-Hill. Everything around here in the United States largely shut down. So the middle of March, things didn't really shut down until I guess April. But my family had decided we were just going to stay in. Every spare moment I had, working late at night, had to basically use a compressed schedule, so I had to work overtime. Basically, that's what you have to do if you have a compressed schedule. Is you have to work overtime to achieve your goal, and I did that. I would get up early, especially on the weekends. I would get up early in the morning, start working on it, and then work on it late at night. I have a small son, so it's kind of busy when he's up and about, but he takes a nap during the middle of the day. So even on the weekends when he was napping, I was working on the book. So it was a lot of effort, but I had already written a lot of it. Some of it was a matter of taking things out. So I had a whole chapter or half a chapter on the high cost of defense and aerospace. Well, I don't know about the high cost of dams, for example, so I just took that half chapter out. So some things were a matter of taking things out, but then I had to replace that with examples of cost and schedule growth across a variety of industries. The California high-speed rail is a good example of that. Originally intended to provide high-speed rail between San Francisco and Los Angeles, the current scope has been cut to two smaller cities in between that actually parallels a major highway. So it's a mega project that's probably going to be a mega waste, over $10 billion to build this rail. Another project in Italy, that's called Moses, or in Italian Mosè, is designed to keep the floodwaters out of Venice as the sea levels rise due to climate change. It's taken so long that the climate change forecasts evolved over time. So the project's actually obsolete and it's not even done yet because it's designed to protect to a certain level of sea rise, but the sea level is now forecast to rise above that, so it's not going to help as much as intended. So did a lot of research in that. It's fun to look at these other projects and see how similar they are to defense and aerospace. And it's not that defense and aerospace are unique. It's that the thing that's common to all these is we're all humans and we all have our biases and innate tendencies, and they affect all projects.
That was a nice preview of some of the stuff in that's going to be coming up in your book, and I'm looking forward to reading it. It sounds like it's useful definitely not just for estimators, but anyone sort of in project controls or project management. It even sounds useful to who might not be directly in sort of as a project professional. What do you think is the core message in your book?
The core message is risk is important. We tend to underestimate risk. No matter how much you think the risk is, it's actually going to be riskier. It's always riskier than you think, even when you take into account that it's riskier than you think. So one key thing is we need to pay more attention to risk. The second part of that is that a little bit of attention would go a long way, because if you're a company trying to gain a competitive advantage, if you will institute some risk management practices, you will gain a competitive advantage because most people are not doing a good job of this. So if you just do a little bit of it or do it relatively well, it'll go a long way to helping you succeed.
Given that technology has moved on and we now have we have the Internet of Things, we have big data analytics, we have a large amount of automation. AI, although some people would argue that that is just high standard statistics merged with computer science. What do you think are the key elements of the way industry is going that will affect estimating? What estimators need to have in terms of competency going forward?
That's a great question. So the industry is evolving. The advent of big data is here. As estimators, we need to adopt these practices. I am keen on these approaches. We have machine learning, which are to some extent very advanced ways of producing averages. That's one piece of this. So we still need to keep risk in view, even when we have better ways to produce what I consider most likely values or average values. Just because you have more data, you're still uncertainty. You may get a little bit of confidence, you may reduce your uncertainty a little bit in terms of your estimate because you have more data, but they're still there. So you need to still pay attention to that. But big data era is here, and we need to pay attention to it. We need to look at these practices and adopt these practices. That includes advanced techniques. So if you think about traditional linear regression or even nonlinear regression analysis, that's been a standard in cost estimating for a while. But we need to also look at things like regression trees, other types of techniques, move a little bit beyond our comfort zone. Many estimators work in Excel. That's their only tool. We need to look at other types of tools like the R, the statistical programming platform. I use that quite a bit. Python is also a popular choice. We need to do some more advanced methods. That's one area. We need to also look at things like natural language processing, which will help us gain insights from textual documents like statements of work. There's something to be gained there in terms of getting some insights into the cost of a program or the schedule of a program. We need to look at those things. One of the nice things about the advent of big data is the potential to get more data and lower level data and to get it faster. In the Department of Defense, there is a move to have contractors report to lower levels something called a flex file format, which stands for a flexible file format. What they typically have produced in the past was a very rigid format that's like something that came from a typewriter era, something that you could actually fill out with a typewriter. Way beyond that stage now, and the Department of Defense is actually moving forward with lower level formats and things that are flexible that for your needs and can provide lower level data that come hopefully directly out of the contractor's accounting system to provide lower level accurate data. So that's one thing, is that getting more data is better. We can provide more accurate estimates. We can get more updates. Instead of, for example, getting a cost report once a year, we can potentially get it once a quarter or once a month. That will help not only cost estimators, but also help project control professionals, because to really understand if a project's kind of going off the rails, so to speak, you need to understand that sooner rather than later. So that also will help with not just cost and schedule estimating, but also project controls. There's a lot of things that the big data era can definitely help, and we're moving in that direction. If you're an estimator, a cost or schedule estimator, and you don't look at some of these techniques, you're going to be left behind. So you need to, for your own professional development, you need to adopt these approaches, because there's a lot of people out there that know about these approaches, and if you don't adopt them, then they will come along and potentially replace you at some point.
People who come into estimating roles, I mean, from my experience, like you said, they weren't estimators at the outset. They weren't growing up to become estimators. It's something that, because of the skill set that you have, is something that matches you. But if the requirements of that role change significantly and rapidly, it's like anyone in the workplace at the moment. You need to be adaptable. You need to have a diverse range of skill sets, but you also need the ability to learn new ways of working. And it's almost like, right, you need to upgrade your armor, or you need to upgrade your weaponry. So I think the advice you gave there is great. And so it's been a really, really good and insightful discussion with you, not least for myself. Just before I say good day to you, where can people follow your work? And again, just to remind us of when the book's coming out.
Yes, so it's coming out November 3rd. And again, the title of the book is Solving for Project Risk Management. You can find it on Amazon and Barnes & Noble for pre-order now, coming out November 3rd, ebook and print versions. I have a blog, christianbsmart.com. The B is for boy. My middle name is Boyd, Boyd. So on school rolls, it was Smart Christian Boyd, but sometimes there was not enough space for the D, so it would come across as I would look like I was Smart Christian Boy on the school rolls. So if you want, it's one easy way to remember my name is think of me as a Smart Christian Boy. So christianbsmart.com is my blog. So you can follow my blog posts there. I talk about risk management. I've done some data analysis on COVID-19 and how it's affected the world. One of the key things I found is mask work. So everybody wear your mask. And that's one place. Also, I've started a podcast recently with a colleague of mine, Doug Howarth, and it is on SoundCloud, ME Evaluators.
I love that. You posted it on an article the other day, and I checked out the SoundCloud, and it's great. And what I'm looking forward to is at some point you coming across the cost estimating a soccer player and how a football club makes a decision on buying a certain player. I'm really looking forward to know. If you want anyone to come on and talk about that, I might talk your ear off about why would someone spend £200 million on a football player.
Oh, excellent. Yeah, I'd love to hear your thoughts on that. So yeah, we'd love to have you on our podcast. The podcast is called Smart Remarks, Howarth States, and my blog is called Smart Remarks. So so we'd love to have you on our podcast. And so I'll talk to Doug about that. Yeah, definitely. And I think Doug might be a good guest for your podcast as well. He has his own unique take on things. He does a lot of work in trying to find value space, looking at the demand curve. And so he can explain, for example, why the DeLorean car, is the Gullwing car that was introduced around 40 years ago. It was really a flop, and he can explain that by basically showing that for its performance, it was well overpriced. And that's something that many companies do not look at. Is they don't look at how are they pricing something relative to the value that's providing. And if you don't find that right spot, you're not going to succeed.
Definitely have to get him on. You'll have to talk him into it. But no, I really appreciate you taking the time. Thank you so much, Christian, for joining me today.
Oh, I really enjoyed it, Emmett Paul. I really enjoyed it. Thank you for having me on.
And that's it for this week. All the links for what we discussed are in the description. Let me know what you think of the episode and follow me on Twitter at CostOfPodcast. The next episode is out in 2 weeks' time. So until then, goodbye.